For this first lesson, we're going to look at Euler paths. So even though it looks like it's spelt Euler, this Swiss mathematician's name is pronounced Leonhard Euler. And he lived in a Prussian town called Königsberg by the Baltic Sea. So when he was living there, he was trying to figure out, is it possible to visit all the parts of the city by only crossing each bridge once? And we kind of have a more simplified layout up here so you can see the bridges better. But what we're trying to figure out is, would it be possible to tour along this path by only crossing every bridge exactly one time? So you can start to try a couple of routes and see where it gets you. Usually you can make it almost work, but then you're left with always one extra bridge. Whether I choose to go to 5 or 1 is going to be left over. So after trying a few different routes, you'll probably start to notice that it is impossible, which it is. It's an impossible problem to solve no matter where you start. But it would take a long time to go through and try every single pathway. So what he kind of came up with was a way to look at these in graph form, and it kind of created what we now know today as graph theory. So we're surrounded by all of these different networks and things in the real world: roads, railroad tracks, phone lines, internet, etc. So what we can do is create them into these more simplified graphs, which is a collection of vertices, which is just the plural for vertex. Those are all the points that you see on the graph, or the dots. Those are going to be connected by edges, which look like the lines in between those dots. Okay, and then there's a few other ways to classify the graphs. We can do the order of a graph, which is how many vertices does it have. So here we have 5 dots, so the order is 5. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So that's an order 8 graph. If we're looking just at one particular vertex, so this darkened dot right here, and we want to know the degree of that vertex, that's going to be the number of edges which meet at that vertex. So we're not counting all the lines, just the ones attached to this dot specifically. So we have 1, 2, 3. That is a degree 3 vertex. Here we have 1, 2, 3, 4, 5, 6. So that's a degree 6 vertex. So what I want you to try on the next page is to look at these different pathways and see if it's possible to draw it without lifting your pencil off the paper and without drawing any line twice. So think about it as crossing the bridges. You don't want to cross a bridge more than once. It's okay, though, to go to the same piece of land. As you noticed here, we went to the middle section twice while on our pathway to try to cross all the bridges. So it's okay if you cross through a dot more than once. You're just trying to trace over every line exactly once. So these are actually the same as these down here. What I've done is I've just kind of lightened it so it's easier for you to tell which pathways you've taken and started on. So I want you to try these and see which ones you can figure out are possible. I will tell you that 2 of them are impossible out of this list. So if you find one that's not working, skip it and try the others. I want you to pause and try this for a few minutes. This house-shaped one is probably similar to one you've seen in the past. That's the most common one that you might have seen already. But if you want to try all of these, just pause for a second the video and try those out. Okay, if you didn't have time to pause, go ahead and do that now. But I'm going to go through and kind of show you a couple of different ways that these ones could be possible. There's lots of different pathways, so there's no one correct path, just as long as you don't cross through the same place twice. So I'm going to start mine down here in the corner, and I'm going to go up and around this triangle. I might come down this way next, over, and notice that I'm touching through this dot again, but it's okay because I'm not crossing that path. I'm going this direction instead, and then I'm going to go straight down. So I didn't lift my pencil up, and I was able to trace over each edge exactly one time. The second graph was also possible. You could have started either here at the bottom or here on the left, and it should work. So try one of those starting points. to see if that kind of helps give you a clue if you couldn't figure that one out. And then on this one, I will tell you that this was one of the impossible ones, so we could not do that one. This is the other impossible one. Among the others, this one was possible, and you should be able to start on any dot and make it work. But on this one, you specifically would need to start on this dot, or you could have started on this dot as well. And either way, you should be able to complete the pathways necessary. So let's check some of those other graphs now. Pause if you want a little more time to try it. This one, you can trace through the outside first, and then you can kind of come inside and create the 4. Or you could have gone inside and created the 4 first and then gone around the outside, something like that. For this one, again, as we said, we could start anywhere. You can either go all the way around the outside first and then complete the inside square, or make the inside square first and then go all the way around the outside. And it's going to work either way, starting from any spot. This one here, specifically, you need one of those 2 places to start. And you also kind of want to just go around the outside boxes first. And then you can cycle back to the inside. And so then there's a completed pathway for you. Okay, now, any route that traces through a graph and only hits every edge exactly once is what we call an Euler path by that same mathematician. And we can tell which graphs have an Euler path based on the vertices with an odd degree. So as I mentioned on the last page, a vertice degree is how many lines are coming off of it. So for this circle right here, this is a degree 2 vertice because there's 1, 2 legs attached to it. This one here has 1, 2, 3, 4, so that's 4. Same on this side, same in the middle, 1, 2, 3, 4. Now, these bottom 2 are 1, 2, 3. That's an odd number, and that's an odd number. Looking at this one, we have a 2 here, 1, 2. This one has 1, 2, 3, 1, 2, 1, 2, 3, 2 here, 3, 1, 2, 1, 2, 3, and 4 in the middle. Now, it says to look at how many odd degrees it has. This one had 2 odd degrees, and it was a shape that we were able to do. This one had 1, 2, 3, 4 odd degrees, and this one was impossible. So the actual exact rule is that as long as there are at most 2 vertices with an odd degree, then we can make an Euler path. So if we go back and look at those ones that we did up here, this one only had these 2 odd degrees. Here, we had an odd degree right there, and we had an odd degree down here. And everything else was even, 2, 4, 4, 2, 4, 2. And notice that I also told you that you had to start at one of those 2 points. So finding the odd number can also tell you where you have to start in order to make the pathway work. Here, all of the dots were evens, and that's why you could start anywhere. Because if it's an even number, you just have to pass through it one time and exit through it one time. But once there's 3, you have to kind of go in and exit and come back to it. So that's why you can't have more than 2 of those. And again, here we had 2 odd spots, and those had to be your starting points in order to make it work. And then everything else is even in this graph. So going back to our bridges problem, the bridges in Königsberg. If we were to take this and kind of draw it out into a more simplified shape. So here we have this picture. This is the original picture we had. And then what we do is we take each piece of land and create a circle. So there's 4 pieces of land. That's what creates this 1, 2, 3, 4 circles. And then because there are 2 bridges that connect these 2 pieces of land, we're going to connect them 2 ways. And then this piece also gets 2 bridges from here to here. And that's where these 2 lines come from. and then we cross this bridge 3 is in the center right here, but the top piece of land also can connect to the side and through the bottom through bridges 4 and 7. So that's how we are able to create this graph. And then we check how many pieces are coming off of it. 1, 2, 3. This one has 1, 2, 3, 4, 5. This one has 1, 2, 3 attached to it. This one has 1, 2, 3. So these are all odds. So that's why this one is impossible. Because there's more than, as long as there's more than 2 odd numbers, it will be impossible to complete that. And if you take a look at the worksheet here, this same kind of graphing problem is what you're going to start with, where your graph should look very similar to this when you draw it over here. But what we've done is we've actually taken one bridge and erased it. So you'll get rid of that one bridge here. That's going to change these numbers and then see if it's going to be possible. You don't have to draw the pathway. You just have to say yes or no if it's possible. And then do the same thing over here, but instead of taking away bridge number 3, we're going to add one bridge from the top to the bottom dot. Create some dots on these with connections. Remember that each piece of land is the dot and the bridges are the lines. On the back is where I want you to specifically tell me what your path was. When you list the Euler path, you would write it with your letters in order like this. And that would show me which path you took so I can follow along. All right, so that is everything for Euler paths.